Here's a shocking revelation. Our brains might not actually reorganize themselves after an amputation, challenging everything we thought we knew about neuroplasticity. But here's where it gets controversial. This groundbreaking discovery could upend how we treat phantom limb pain, a condition where amputees feel pain in a limb that's no longer there. Could decades of treatment approaches be based on a flawed understanding of the brain? Let's dive in. For years, scientists believed that the somatosensory cortex, the brain region responsible for processing touch, temperature, and other bodily sensations, could rewire itself after an amputation. For instance, studies in macaques showed that neurons originally linked to a severed arm began responding to facial touch instead. This led to the widely accepted theory that the brain remaps itself, reallocating functions to compensate for the loss. And this is the part most people miss. While this idea sounds intuitive, new research suggests it might be entirely incorrect. Tamar Makin of the University of Cambridge and her team conducted an unprecedented study, tracking the brain activity of 3 individuals before and after their arms were amputated. Using MRI scans, they observed the participants' brains as they performed simple tasks like pursing their lips or tapping their fingers. Shockingly, even years after the amputation, the brain signals remained unchanged. When participants imagined moving their missing fingers, the same brain regions lit up as before the amputation. Isn't that mind-blowing? To double-check their findings, the researchers trained an AI model to identify which brain scans corresponded to specific finger movements pre-amputation. Post-amputation, when participants imagined moving their fingers in random order, the AI accurately matched the brain activity to the correct finger, proof that the brain's wiring hadn't shifted. But it doesn't stop there. The team also compared the somatosensory cortex activity of recent amputees with individuals who had lost their arms decades ago. The results? Virtually identical. This suggests that the brain doesn't switcheroo its functions over time, as previously believed. John Krakauer of Johns Hopkins University puts it bluntly. The idea that the cortex can simply reorganize itself is incorrect. This isn't just an academic debate, it has real-world implications. Many treatments for phantom limb pain rely on techniques like virtual reality to encourage brain rewiring. If the brain doesn't actually rewire, these methods might be ineffective, with any perceived benefits stemming from the placebo effect. So, what's the alternative? The researchers propose that preventing phantom limb pain might involve grafting nerves into new tissue during amputation, stopping the remaining nerves from thickening and causing pain. But here's the question that'll spark debate. If the brain doesn't reorganize, should we rethink how we approach rehabilitation entirely? Could this shift our focus from retraining the brain to addressing the physical causes of pain? This study doesn't just challenge a scientific theory. It invites us to reconsider how we understand the brain's limits and potential. What do you think? Is this the end of the road for neuroplasticity-based treatments? Or is there more to the story? Let's hear your thoughts in the comments.